In example 5, we are told that it costs you $250 to make 7 units of a product and $400 to make 120 units. You decide to sell the product for $5 a piece. In part A, we're going to find the cost equation, assuming that the cost is linear, and then interpret the slope and the intercept in this context. In part B, we're going to find the revenue and profit equations, and then in part C, we're going to find how many units we have to make and sell to break even. To find the cost equation, assuming that the cost is linear, that is a key phrase here, we have to understand that we're looking for a formula for cost, which we represent as uppercase C, and this is going to be always in terms of x, where x is the number of units. Always in economics questions here, x is the number of units made or sold or both. Items made, sold, or both. In this example, it says that the cost equation is linear. So that means that the cost is going to look like mx plus b. In past economics examples, we were often told what the fixed cost was and the variable cost, and then we could put those together to find our cost equation. Here we are actually not given that. We only know the amount it costs to make 7 units of this product and then 120 units of this product. So here what we have is basically two coordinates that will lie on the cost equation. We could organize this information in coordinate pairs, or we could make a table or a chart, or maybe let's do both. It's really important to make sure that we have our x and c values in the right spot. So we've got this pair here of $250 and 7 units. Now 7 is an x value because that is the number of units. And the cost that goes with that x value is 250. Then we also have this other pair, $400 and 120 units. Now those go together as well, and we know that x is units, so that's 120, and cost is dollars, and so that's 400. If we wanted to write these in ordered pairs or coordinates, we could do that too. It's going to be x comma c instead of x comma y because really c is playing the role of y. So if we put our first pair into a coordinate, we would have 7 comma 250, and our second pair would be 120 comma 400. Now to find the equation for our cost, we are still looking for the value of m and the value for b. Here we have 2 points, so we can find the slope between them. So let's do that first. So instead of y2 minus y1, we're going to have c2 minus c1, or a change in cost, because that's playing the role of y. Here we're using x, so we can say x2 minus x1. Again, if you like the deltas, we can do that too. Just make sure we're using c instead of y. So the change in cost, I'm going to call this the second coordinate and this the first coordinate, or the second ordered pair and the first ordered pair. So our second cost will be 400, and our first is 250. And then the 400 goes with 120 units, and the 250 goes with 7 units. So 400 minus 250 is 150, and 120 minus 7 is 113. If we divide 150 by 113, that gives us about 1.33. Now remember that this is dollars, so we can round to two decimal places and that should be okay. Now we have to find the value of b. What we can do is, again, substitute in one of the points that were given. I'm just going to use the one that has the smaller numbers here. Just make sure that you are plugging these into the correct spot. So it's x comma c. So I'm going to plug in 250 for cost, and I'm going to plug in my m value, and it's probably best to just use this exact value, that's the fraction here, at least until we get a final answer. And then our x value that goes with 250 is 7. So if we solve for b by subtracting this whole thing to the other side here, we will get about 240.71. Remember, this is dollars, so again, we can round that to two decimal places. And remember, we're looking for the cost equation, or the cost formula. So we're going to put these together into our c equals mx plus b. So our m value was about 1.33. That gets multiplied by x, and the value of b was 240.71. So here is our cost formula. Now, if we'd like to interpret the slope and the intercept in this context, we actually can now remember what we learned before about the cost equation. The cost equation will always have this form where the value that's multiplied by the x is the variable cost, or the cost to produce one item, and the b value, the intercept, can be thought of as the fixed cost. So this is the amount that we have to pay if we're not going to produce any items. Maybe it's to rent a space or to rent a machine or something like that. So this 133 means that it costs us $1.33 to produce one of these items. And then this fixed cost or intercept is the amount to pay for producing no items. Bringing this back to what we were talking about regarding slope being a rate or a ratio, the units for the cost slope here, it is change in C, change in cost over change in X. So the units for our cost slope will be dollars per item. And remember that slope tells us the change in the y, or in this case c, when you are to increase your x values by 1. So this $1.33 tells us if we were going to make one more item, then our cost is going to increase by $1.33. For part B, we are going to find the revenue and the profit equations. Now, we reviewed these formulas a while ago, and you will need to know them throughout the semester, so probably a good idea to memorize them as soon as possible. But the revenue formula is always going to be price times X. Sometimes your price is a formula involving X as well, but sometimes it is just a dollar amount. So price is the amount that you're charging per item. It's the price for the customer. So here we have $5 per unit that we're charging. So our revenue is going to be just 5 times X. Now our profit equation, using capital P to distinguish that between price, and that's always revenue minus cost. So revenue is 5X and cost is 1.33X plus 240.71. And be careful when you're subtracting costs. We will always need parentheses around it because it's going to consist of more than one spot or more than one piece. So we need to make sure that we're subtracting all of it. Then we can distribute the negative sign into the cost just to simplify this a little bit. Then we see that we have some like terms that we can combine together. We've got 5x minus 1.33x, and so that gives us 3.67x minus 240.71. So here's our revenue equation, and then here is our profit equation. Now in part C, we want to know how many items should we sell in order to break even. So remember that breaking even means that we don't make a profit at all. So we could either set our profit equal to 0, or it's where our revenue and our costs just balance each other out. So where those two are equal to each other. We already found a profit equation, so I'm just going to use that one, but you'll get the same thing either way, whichever one that you like. So if we set the profit equation equal to 0, we're just going to set the formula that we have here with x equal to 0. Now all we have to do here is solve for x. So we should probably add the 240.71 over to the other side. And then we'll just divide by 3.67. And if we divide 240.71 by 3.67, we will get about 65.6. Now, it doesn't matter to me if you were to round up or down or leave it like this. I could see reasons for either situation. So just be careful in things like WebAssign where it should probably tell you what to do with that. But for these purposes, we can just leave it as either about 66 or 65 units.